so the unit will be in Pascal, right? So what does this mean? As you remember, here is the static pressure at this location, pressure at point, and then we have a dynamic pressure because of the velocity. So the velocity create the dynamic pressure, and then we have the hydrostatic pressure, right? So hydrostatic pressure is the when the fluid at rest, right? So we have that values, and later on we're going to find that this mgh is due to the weight of the body. Now this one in pressure unit, we can also write them in the unit of head, right? So what is the unit of head? When we divide this equation with density and gravity, right? So we have P divided by rho G, and then we have the plus V equals to 2G, and then we have Z, right? So if we consider previously the pipe flow, this is a velocity distribution, and then we have the orifice there, pressure orifice, and we connecting the tube. So this one is at this location is P divided by rho G, the pressure of the fluid, right? Because this fluid, because the size not so big, we can say the pressure here and the pressure here is almost the same. So that is the contribution. And then we have the dynamic pressures is the pressure of the fluid as it moves, right? And Z will be the pressure here. If we have the pipe is going up like that, so we have another different pressure due to this head, right? And finally we can write this equation in terms of energy, right? So we have going to write this equation in terms of energy, in terms of, for example, joule. It's not maybe joule, I think it's watt better, right? Because we try to write this equation based on the something that we can measure using the sensors. So how we can get the value of watt? The watt can be obtained by multiply this equation with the mass flow rate and divided by density. So we have mass flow rate times the pressure divided by density plus m dot V equals to 2 per 2, right? And then m dot Gz equal to constant. So this one will be in the form of energy, because we can use, let's say we have a pipe, we can place an orifice. This is the orifice to measure the flow rate, the mass flow rate, right? By looking at the pressure at these two different locations, we can get the mass flow rate. We're not going to use laser Doppler and then to get the mass flow rate. So, and then measuring or measuring the energy of fluid particles is not possible. So we can represent this equation in terms of it. So we have a flow work. Here represent flow work. And then we have this kinetic energy, and then we have this potential energy. For this head, we have this what we call it as a static head. Static head. We have a dynamic head, and then we have hydrostatic head. So this is normally what they call it, or potential head. So hydrostatic head. What about this one? We can call it static pressure, right? And then we have this dynamic pressure, and then we have this hydrostatic pressure. Right? What is the hydrostatic pressure? You should refer to your quiz. I think quiz last week quiz.